Hello, Professor. My name is Ichiro Tao. So today I'm going to present my work on assignment 1, question 1 for the AI programming course. This assignment focuses on using deep neural network to classify the UCI abalone dataset. The main objective is to first additionally create various regularization techniques. So this notebook is organized into several main sections. We can roll it down for watch first. So I'm gonna start from the part A. So as you can see from the part A, um, it's about the data loading and the processing. Here, I split the data into 50% training and 50 validation sets as required. And next be the part B. So I'm training an internally overfitting model for 100 epoch. And for the part C, as you can see, it's about improving the model by turning hyperparameters to reduce overfitting. And for the part D, is improving the visualizing the architectures of both models. So let's start the more details from the part A. So let's start with the data processing part. The abalone dataset contains physical measurement of the abalone, and our task is to predict their sex based on this feature, male, female, or infant. So here I use the panel to read the CSV field. I define the column name manually because the original data file doesn't have a header. The dataset has 4,177 records with 9 features. Then I use a label encoder to convert the sex labels into a numeric value. So F equal 0, I equals 1, and M equals 2. I wrote this part myself to refer in the scikit-learn documentation for the correct syntax. And also next part is the train test spelled. I use the train test spelled to divide the data. Then test size of 0.5 means as a 50-50 spelled. And the stratify parameter ensures that the class distribution is maintained in both training and validation sets. So finally, I use a standard scalar to normalize the features for this part, which is crucial for neural network training. This entire pre-processing pipeline was designed by me and based on what I learned from the course. So we're gonna continue to the part B, the build overfitting model. Now let's move. Let's see. I designed the a very deep network with the 6 hidden layers, and the neural counts 512, 512, 256, 256, 128, 128, and finally 3 output nodes for the 3 classes. Why did this RT central overfit? There are 3 main reasons. So first, the model the cavity is too large. It has over 500,000 parameters, but we only have about 2,000 training samples. The second is there are no regularization techniques, no dropout, no L2 regularization, and no batch normalization. And third, I only use a simple value activation function. So the model is trained for 100 approach using the atom, automizer, and the sphere categorical. As we can see, the abalone B picture, as looked at the training history graph, this clearly shows overfeeding. The blue training loss continually decreased to 0.28, but the orange validation loss shoots up to 2.663. The training accuracy is reaches 88%, with evaluation accuracy stay at only 52%. This gap indicates the model has memorized the training data but fails to generalize to the new data. So it's exactly what the assignment requires, which is a demonstration of overfitting. And we can take about the model C. Part C is about the improving the model. Um, I applied the I applied to the mutable regularization technique here, and we built the improved model to looking at this new architecture. I made several key changes. First, a simpler structure, only three hidden layers with uh 1 to 8, 64, and 32 narrows. This significantly reduced model capacity. Second, L2 regularization, each dense layer has a Q neural regularization layer set to L2 with a value of 0.0001, which penalize a large weights. And the third is a batch normalization. So I add a batch normalization layer after each dense layer to stabilize the training process. And fourth, drop out the I add the dropout with the rates between 0.2 and 0.3, which randomly drops the narrow steering training to prevent overfeeding. And fifth is a better active function. I replace the with a leaky redo to avoid the dying problem. So all these hyperparameter value like L2 equals to 0.001, and my understanding of this technique and the recommended range from the documentary. And now let's look the improve model training history about model 3. The training loss and the visualization loss are very close to each other, both around 0.83 to 0.88. The two curves almost overlap, which means the overfitting problem is solved, and training accuracy is 60%. Validation accuracy is 56%, with only 4% gap. Although the overall accuracy is lower than Model B's training accuracy, the generalization ability is much better. So this demonstration, the bias variable trade off the perfectly. And for the part D is use about the key search to verify the model architectures. So this abalone DB picture. This is the overfeed model. Look at the steps, 6 layers stacked on the top of each other. Each layer is very wide, resulting in a huge number of parameters. And this is a improved model. You can clearly see the patterns. After each descent layer, there's a batch normalization layer, so followed by the leaky roller activation, and then drop out the layer. There's a repeating patterns reflecting my regularization strategy, and this two diagram clearly shows the difference in model between the overfitting and the improved architectures. Now we're gonna say about the performance compression. So let's look at the final performance compression. So model B, the overfitting model training accuracy is a 89.6%. As you can see, the validation accuracy is a 51.8%. The overfitting accuracy is overfitting gap is 37.8%. So for the model C, the improved one, the training accuracy is 59.9%. Validation accuracy is 55.6%, and overfitting gap is only about the 4.3%. So the key metrics show that validation accuracy improved by 3.7%, overfitting gap was reduced by 33.5%, and the validation loss decreased from 2.85 to 0.88, an improvement of the 1.97. So this clearly demonstrates that the regulation technicals significantly to improve the model generation ability. So to summarize, in this assignment, I have successfully created an overfitting model that demonstrate the problem clarify, signify improve the model using multiple organization technicals, and I applied and understood the concept of overfitting and the regularization, and honestly document the code source and my use of AI assistants. So thank you for watching. If you have any question, please feel just let me know. And this is my presentation about 7.1.